All right, you may recall the last assignment I had you do, you went through this exploring inverse functions assignment. The first thing I asked you to do is look at these two tables and tell me what you noticed about them. These are inverse functions. Hopefully, you noticed that all you did was switch the x and y. So you should have said switch the x and y values. For example, you notice that here on f of x, our first coordinate point is -2 for x and -2.5 for our y value. And on g of x, they just traded places. -2.5 became the x value and -2 becomes the y value. Now please notice that we didn't change any signs. All we did was switch the x and y. They just traded places. Now, here on the next one, I gave you two graphs and asked you what I had done to one graph in order to get the other. These are also inverse functions. So the first thing you may have noticed is that these are actually reflections of each other across the line y equals x. So, for example, if I draw in this line across my y-axis, or excuse me, if I draw on this line y equals x, do you notice how g of x just reflects onto f of x? They're mirrors of each other. In fact, if you take a mirror and put it on that line y equals x that I just drew in, you'll see that graph reflected onto itself. We also recognize that they're inverses because we can look at the individual coordinate points. For example, here on f of x, this point that I'm marking is the point 5, 1. Well, if I switch the x and y, I get the point 1, 5, which is this point right here. And you notice that that point is on my g of x function. So that's another way that we can spot an inverted function is, again, we just switch the x and y. We also recognize it's an inverse because we have reflected across the line y equals x. All right, now this last section was a little tricky. Question 3, I gave you these two functions, f of x and g of x, and I told you they're inverses, and I asked you how we can find the inverse from an equation. Well, remember how the first two examples, all we did was switch the x and y. So here on these equations, again, we're just going to switch the x and y. So watch how this is going to work. If I take my f of x, well, let's start with our g of x function. So if I take my g of x function, and I'm going to write it as y equals 2x plus 3. Well, if I switch the x and y in this equation, it will become x equals 2y plus 3. But when we write equations, we like that y to be alone. We don't usually leave the x alone. So to get the y alone, I'm going to go ahead and subtract the 3 over to the other side. That will give me that x minus 3 equals 2y. And then, since I still want the y alone, I need to get rid of the 2, so I'm going to divide by 2. And when I divide by 2, I do it to everything in this equation, which gives me that x minus 3 over 2 equals y, which you notice is our f of x function. So I can tell that yes, indeed, these are inverse functions. Now, on this assignment, you're going to be doing exactly what we just talked about. You're going to be finding the inverse function. Problems 1 and, sorry, this is supposed to be a 2, not another 1. Problems 1 and 2 are asking you to find the inverse function from a table. So remember, back in our example 1 up here, when we found the inverse from the table, we just switched the x and y. So you're going to be doing that here on these tables. On numbers 3 through 8, you're going to be finding the inverse based on the graph. Now, if you have a mirror or even your phone, you can place that mirror or phone along the line y equals x and see what the graph should look like when you draw it. But to actually get the graph, I like to use some points. So here on number 4, I'm going to start with this point 0, 0. Well, if I switch the x and y, that point becomes still 0, 0. So I can see that that point's not changing. But then I'm going to take this point right here, who looks like he is the point 4, 2. If I switch the x and y there, that point becomes 2, 4. So I find the point 2, 4, there it is. And then, just to get a really good idea, I'm going to do one more point. Let's use this one right here. This is the point 10, 3. If I switch the x and y, I get the point 3, 10, which 3, 10 is right here. And if I connect those dots, I get a graph that looks like this. This right here is what we call the inverse function, and a lot of times we write it like this, f inverse x. This little -1 right here that I just wrote means inverse. And we use that symbol a lot to represent inverse. So I'm going to let you go ahead and do problems 3 through 8. Let's look now at problem 9. It says, for each function, state the domain and range, then sketch f inverse of x. There's that inverse again. Sketch f inverse x and state the domain and range. Finally, state whether f inverse x is a function. So the first thing I'm going to do is for this function graphed here on problem 9, I'm going to state the domain and range. Remember that domain is your x values and range is your y values. So here on this graph on problem 9, it's a line. If we think about the x values, the farthest down the lowest x value we'll ever get to is -infinity. And the farthest up, the highest x value we'll ever get to, the farthest to the right we'll ever go, is +infinity. Okay? Well, if you look at your range, it's going to be the same thing. On our range, the lowest down, the lowest y value we'll ever go to is -infinity. And the highest up, the biggest y value we'll ever get to is +infinity. So there's our domain and range for this original function. Now I'm going to go ahead and graph the inverse. And to do that, I'm just going to take a few key points. So for example, here I have the point 0, 6. Well, if I switch the x and y, that becomes the point 6, 0, which is right here. Then I'm going to go ahead and do just a few more points. So maybe I'll use this point right here, who looks like he is at -6, -6. Well, if I switch the x and y, I'll get -6, -6. I'll have that same point. So now, if I draw this inverse graph, it's going to end up looking something like this. Okay, so there's my inverse. My inverse domain. Well, domain, remember, is the x values. So the lowest x value, the farthest to the left that this graph ever goes, is -infinity. And my highest x value, the farthest to the right my graph will ever go, is +infinity. Okay, for my range, remember those are my y values, ups and downs. So heading down, the lowest down this graph will ever go is -infinity. And the highest up, the biggest y value I'll ever go to, is +infinity. Okay, last question is this a function? Well, remember that to be a function, for every x value we put in, you can only have one y value coming out. In other words, I should be able to draw straight up and down vertical lines anywhere on this graph and only hit the graph one time. Now, I'm only looking at my pink line graph that I've drawn. I'm not worried about the original. But if I draw straight up and down lines here on this graph, can you see how I'm only crossing that pink line once every single time? So I know that yes, this inverse is for sure a function. Okay? Last but not least, this last section I'm asking you to find the inverse of each of these functions. Now remember that to find the inverse, all we have to do is switch the x and y and then get the y all by himself. So for example, here on problem 17, I'm going to write this problem as y equals x minus 6. Because then I can switch the x and y. I'm going to rewrite it as x equals y minus 6. And then if I want to get the y alone, I'm going to add the x, or excuse me, add the 6 over to the other side. Well, if I add 6 on both sides, that gives me that x plus 6 equals y. Y is now alone, and I know that this is my inverse. Okay, I'm going to have you try all of these, except you can go ahead and skip problem 22 and skip problem 25. And while I'm thinking about it, go ahead and skip problem 16 as well. Okay, but the rest of these I think you should be okay and be able to do. So I'm going to let you go ahead and try them out. Good luck.